Good morning, students. Mr. Carver here. Today is section 5.2, the natural log functions, and today we will be talking about integration. All right, if you recall the video from 5.1, we know that the antiderivative of 1 over x dx turns out to be the natural log of the absolute value of x plus c. Actually, in 5.1, we started with the right-hand side and moved to the left. Now we're just going to be going in reverse. This should be added to your memorization list. And again, more broadly, if we have something other than x, we can use this form. This is the integral of 1 over u du. This is what you would get if you use u substitution, and I will work through several examples showing you how this works. You get the natural log of the absolute value of u plus c, at which point we would then replace the u with our expression in terms of x to finish out the problem. So let's look at a couple of examples. Start off with an easy one here. 1 divided by 4x plus 6th quantity. Remember, you have a formula for 1 over u or 1 over x. You don't have a formula for 1 over 4x plus 6. So in many ways, this models the prohibition list when we first started encountering integrals. Quantities other than x raised to a power, I think you would agree that 4x plus 6 in this case is raised to the negative 1 power. This is also a quotient, which is just another way of saying what I just said, basically. So we need to use u substitution to get it into one of these two forms. I'm going to let the denominator be u. I can turn the entire denominator into a single variable, allowing us to use that formula on the right. And just like normal u substitution, you pick u, that indirectly or directly then determines what your du line, because the next line is just the derivative of the first. So du is equal to 4 dx. I don't have a 4, so I'm going to bring that over to the other side, divide both sides by 4. And now I'm ready to use the substitution using those two lines. This is equal to 1 over u. My dx comes out, and I plug in 1/4 du, which is what it's equal to. And now we're good to go. I've got it in the formula form, and I am ready to integrate. I've got 1/4 out front, the natural log of the absolute value of u plus c. And of course, as I said mere moments ago, I want to take that u out and replace it with my expression in terms of x. So easy enough. Now I should warn you, there will be problems mixed into Chapter 5 that come from the previous chapter that don't require you to use the natural log answer or the substitution of 1 over u du. So if you're looking at the problem and you can do it in an easier way, if you can eliminate a product, a quotient, or a quantity other than x, by just doing division or foiling things out or distributing, do that. All right, as you start these problems, I look at the numerator and the denominator. Keep in mind that it's important when you are using u substitution to remember that when you pick the u line and you derive it, you will have a derivative that is 1 degree less than your u line. And that's important here. You'll notice that the denominator is 1 power or 1 degree more than the top. So we'll just try to let that be u. I've got x to the 4th plus 8x, and now I derive my du is equal to 4x cubed plus 8, which is close to the top, not quite, but I can take a factor of 4 out of both of them and divide both sides by 4. That gives me 1/4 du is equal to x cubed plus 2 dx, which is exactly what I need. So this original integral now, using these three lines, becomes the integral of 1 over u times 1/4 du. By the way, it always doesn't give you 1/4 1 over u du, but in these two cases it certainly does. This is then 1/4 times the natural log of the absolute value of x to the 4th plus 8x plus c. And just a little review from last chapter. If you want to derive this to check it, you got the constant multiple of 1/4. It's the natural log of something, so it is 1 over that something. And then I want to derive the what I'm natural logging, right, which is 4x cubed plus 8x. If I take a 4 out of there, I can cancel it with this 4 in the denominator, which gives me exactly what I need, 1 over x to the 4th plus 8x, and that is going to be times x cubed plus 2, which is what I started with, so it does check. All right, we'll do a quick trig one here. By the way, sine over cosine is equal to the tangent, correct? But unfortunately, I can't convert that using a Pythagorean identity. I also don't know what the antiderivative of the tangent of x is, rather. I can derive it, I just don't know how to integrate it. So I'm going to integrate it using u substitution. I'm going to use this form rather than the tan. U is equal to the cosine of x. When I derive that, I get the negative sine of x dx, which is close. I just don't need the negative, so I divide both sides by -1. And now I'm good to go. I get the integral of 1 over u times negative du, which gives me negative natural log times the absolute value of the cosine of x plus c, which happens to be the integral of the tangent of x. Which brings me to these following 6 formulas for anti-deriving the 6 trig functions. So let's go ahead and start this out. I'd like you to put this on your memorization list. First of all, the antiderivative of the sine of u. And by the way, you'll notice that I'm using u in here so that we can use these formulas with u substitution, as the name implies. The formulas work whether they are an x or a u. Remember that if it's something other than x, you'll use u substitution to get it into this form. So the first one, the sine of u du, turns out to be the negative cosine of u plus c. So I think I need to write this a little smaller. I need to save some room here. This is the negative cosine of u plus c. And then, of course, the antiderivative of the cosine of u du turns out to be the sine of u plus c. The tangent of u, as we just saw on the previous page, turns out to be, oddly enough, the negative natural log of the absolute value of the cosine of u plus c. And again, we can check this, right? If you derive this function right here, I have a -1 out front. It is 1 over what I am logging times the derivative of what I am logging. Whoops. And these negatives cancel, and of course sine over cosine does become the tangent of u, which is why that works. It seems odd, counterintuitive, that you would get such an odd expression for the antiderivative of the tan of u, but you do. All right, how about this? The integral of the cotangent of u turns out to be the natural log of the absolute value of the sine of u plus c. The antiderivative of the secant of u du turns out to be the natural log of the absolute value of the secant of u plus the tangent of u plus c. So these are very difficult to kind of guess and check if you don't have them memorized. It is absolutely worth your while to memorize these. I realize during COVID, you've got lots of choices, but in a typical calculus class, having these memorized makes life much more difficult. There is one more to go. It is the antiderivative of the cosecant of u du, and that turns out to be the negative natural log of the absolute value of the cosecant of u plus the cotangent of u plus c. And of course, as I mentioned before and mere moments ago, you should have these memorized. All right, then all these new formulas will be mixed in with older techniques. Look, this is the tangent of something other than x. Not only that, it's a quotient. So I'm going to use u substitution. I think it stands to reason that u would be my innermost function. That is the square root of x. And when I derive that, I get 1/2 x to the -1/2 dx. I do need the x to the negative 1/2. That gives me my denominator and my dx, but I don't need the 2. So I'll multiply both sides by 2. And now when I do the substitution, I get the antiderivative of the tangent of u times 2 du. And recall from the previous page, I can now integrate this easily because I have a formula for it. This is negative 2 times the natural log, of the absolute value of the cosine of u. We know that's the square root of x, and that is plus c. And that is my final answer. All right, just a few more, guys. Thanks for hanging in. You've got the antiderivative of the cosecant of 5x plus the cotangent of 5x dx. I can actually break this up, right, because I've got a sum in between here. Now, when I break them, remember, the integral and the dx always occur in pairs, so I'm just splitting them up into 2 separate derivatives. You'll also notice that my innermost function is something other than just x, so I need to use u substitution for both of them. In fact, I can use the same substitution because my innermost function for both is 5x. My du then turns out to be 5 dx. Neither one of those has a 5 on the outside, so I'm going to divide both sides by 5. And now when I do the substitution, I get 1/5 times the integral of the cosecant of u du plus 1/5 the integral of the cotangent of u du. And I've got formulas for both of them. So the cosecant is negative 1/5 the natural log of the absolute value of the cosecant of u plus the cotangent of u plus 1/5 times the cotangent, which is going to be plus 1/5 the natural log of the absolute value of the sine of 5x. All that plus c. And that is my final answer. All right, you need to be aware of in this section these things called improper fractions. And if you recall from 5th grade, improper fractions are top-heavy fractions. And the way that you knock down a top-heavy fraction is, yes, you guessed it, long division. All right, so here's what we're going to do. I'm going to knock this down before I actually start integrating this thing. I'm going to take the top, x cubed plus 0x squared minus 6x minus 20. And I'm going to divide that by my denominator. Remember to put in missing terms. So here's what we do. I take the first term and divide the first term by it. So that gives me an x squared up top. I then take that x squared and I multiply it by both of these terms here. This gives me x cubed plus 5x squared. And then just like we did in long division with numbers, I subtract. X cubed minus x cubed, no more x cubed. 0x squared minus 5x squared is negative 5x squared. And then I want to bring down the 6x. And then I do it again. I look at the first term and the first term. Looks like I need to multiply that by negative 5x. This will give me a negative 5x squared minus 25x. And I subtract again. So negative 5x minus a minus 5x squared. Excuse me, those things cancel. They should, otherwise you've screwed this up. Negative 6x minus a minus 25x is positive 19x. I then bring down the 20, or the negative 20, and do it again. Looks like this will be plus 19. This is 19x. Looks like that's plus, is that 95? And now I subtract again. The 19x's cancel. This gives me negative 115. And if you recall the way you write a remainder, it is going to be plus or minus the remainder over the divisor. All right, so really what I'm integrating is this answer here. This is x squared minus 5x plus 19 minus 115, the integral of 1 over x plus 5 dx. All right, now I'll show you why I split these up in just a second. You can split all 4 of them up if you like. But I'm going to erase this now so I have just a little bit more room here. Let's get rid of this long division here. Get rid of all of this. All right, that's a little better. Now, the first three here, you can see, are easy to integrate. So I'm just going to go ahead and integrate these. It's power plus 1 over power plus 1. That gives me an answer of 1/3 x cubed. That's power plus 1 over power plus 1. That's negative 5/2 x squared. And 19, of course, goes to plus 19x. The only question is, what is that last integral going to give me? All right, so let's go ahead and take this over here, negative 1/15 times the integral of 1 over x plus 5 dx. You'll notice here that I need to use u substitution on this because x plus 5 is not x. So my u is x plus 5. My du is dx. This gives me negative 1/15 times the integral of 1 over u du, which of course we know anti-derives to negative 1/15, the natural log of the absolute value of x plus 5 plus c. And that finishes out that problem. So remember, top-heavy fractions or equally heavy fractions, I should mention that as well, you've got to use long division. All right, I just got one more, guys. Thanks so much for hanging in there. I need to talk about this problem here. It does get a little tricky. All right, so by the way, I should mention this. You cannot split denominators. For instance, if you've got 1 over 4 plus 5, that is equal to 1/9. That is not equal to a 4th plus 1/5, which would, of course, would give you 9/20. You cannot split denominators. All right, so in this case, what we're going to do is let the denominator be u, because I'm going to try to force this into 1 over u du. So just like normal u substitution, what I'm going to do now is derive. Remember, it's chain rule for this second part here. 1 goes to 0. That second part there goes to 1/2 2x to the negative 1/2 times the derivative of the innermost function, which is 2, times dx. These cancel. So what I get is du is equal to 1 over root 2x dx. All right, let me pause here just for a second. This is a problem, correct? I've got 1 over 1 plus root 2x, which is 1 over u du, but I can't have du because I've got too much here. I don't just have dx, I'm missing rather 1 over root 2x. So what I'm going to do is this. I'm going to take this root 2x, I'm going to move it over here. This gives me root 2x du is equal to dx, because I really only want that dx here to the right-hand side, because I need u and dx. Or excuse me, I need 1 plus root 2x and dx. Now, the issue with this side here is that I've got u's and x's mixed together. So just like normal u substitution, it's nothing more than an algebraic trick to replace every x with a u. Well, check this out. I know that this line right here can be easily solved for root 2x. So my root 2x turns out to be u minus 1. And u minus 1 can go right here. All right, so let me write down what I know on the right-hand side. I've got u is equal to 1 plus root 2x. I definitely need that. My dx turns out to be, right down here, I've got u minus 1 du. These two lines right here were just transition lines to be able to get me down to the bottom there. So I'm just going to use these two lines right here to substitute into my original. All right, I'm going to erase. All right, and here's what I'm going to have now using these two lines. This is the integral of 1 over u. My dx comes out. I plug in u minus 1 du. Now, just like we've with previous sections, we have difficulty here, right? I've got a product. I also really have a quotient. So what I'm going to do is move this u to the top, u to the negative 1 times u minus 1 du. And I'm going to distribute. This gives me the integral of 1 minus u to the negative 1 du. And now I'm ready to integrate. So 1 rather goes to u because I'm anti-deriving with respect to u. U to the negative 1 goes to natural log of the absolute value of u plus c. And my final step here is I just replace my u with an expression in terms of x. That's 1 plus root 2x minus the natural log of the absolute value of 1 plus root 2x plus c. All right, guys, I know that's a complicated problem. Let me know if you have questions on it. I'm hopeful that will get you through most of the homework. Obviously, there will be questions. I will help you as much as I can, so hang in there. Thank you.